Okay, so I'm going to make this quick video about the equation sheet to review with you. So I'm going to actually start partway down it here with the formula. Force is this guy right here, equals, this is a constant. This Q, these stand for charge 1 and 2. And this is the distance. So this is Coulomb's law. We talked about it, we went through the ideas. You weren't asked to do any problems with the actual formula, but it is on the equation sheet. Let's just review units for a minute. Force will be measured in newtons. Charge, those are measured in coulombs. So C. Distance will be measured in meters, and the constant has a bunch of units there for it. Remember, this is defined, how strong is the force between two charges? So if the charges are bigger, the force will be bigger. If the distance between them is bigger, then the force will be smaller, because this is on the bottom. And because it's squared, it affects the distance a lot more. Another thing to remember about this is that it's similar to the formula for the strength of gravity, which we didn't have to use, but you also saw last semester or in the reading for this semester. And it's a very similar formula. They're both inverse square laws, where the distance is inversely proportional, or the force is inversely proportional to the distance squared. But the thing to remember here is that because the constant here is so much bigger than the constant here, the Coulomb force is much, much stronger, billions of times stronger than the force of gravity. In fact, the force of gravity is the weakest of all the forces. Okay, the next formula is the electric field is force divided by charge. You didn't have to do anything with the formula, it was just mainly concepts for that one. Excuse me. This one is voltage. The definition of voltage is potential energy divided by charge. We did have to do something with that. Remember, voltage is the average, whereas potential energy is the total. The average is measured in volts. Another name for it is electric potential. But the volts, 1 volt is 1 joule of energy per coulomb of charge, because that's in coulombs and that's in joules. This one down here is Ohm's law. It tells you what is the relationship between, or what produces current really. Remember, I stands for current, which is measured in amps. V is voltage, or potential. R is resistance. So that's in volts. This is in ohms, Greek letter. There's the symbol for it, upside down horseshoe. So the current is equal to the voltage divided by resistance. So you can think of it as the voltage tries to produce a current, the resistance tries to fight it. So it's the ratio of those two that tell you how much current you actually get. Current is also coulombs per second. The amps, I should say. So that's the definition of 1 amp, really. This is similar to the idea of acceleration was produced by forces but resisted by inertia or masses. Same sort of an idea, but for current. This is power. Power equals the current times the voltage. We figured that out when we found the cost to run different electric appliances that you had to do at home. So if you have 2 amps of current and you plug it into an outlet with 120 volts, then that gives you a power of 240 watts. So power is in watts, current in amps, voltage in volts. This stands for the velocity, or you could also call it the speed of a wave, whereas this is the frequency. And this Greek letter lambda is the wavelength. So the velocity of a wave is the frequency that it's happening, or times by its wavelength. You can also say The speed of the wave, or its velocity, is the distance, which is also wavelength, but you could divide it by the time, which is the same thing as the period, and that also works. Here this is saying frequency is 1 divided by period. You could also reverse that and do period is 1 divided by frequency if you wanted. Those were the equations that you could use for sound, and also light they work for. Back up here at the top, this stands for pressure, and pressure equals force divided by area. This was some of the stuff we didn't really cover much. Pressure is in newtons per meter squared, which also equals pascals, but there's a lot of other units for pressure, like atmospheres or millimeters of mercury and different things like that. The basic idea is, though, it's force divided by area. So you take the force pushing on a surface, divide by the area, and that would be the pressure on that surface. This right here is the formula for density. That's another Greek symbol, stands for density. And this here is the mass of something, and this would be dividing by its volume. And that is pretty much the equation sheet. Not a whole lot there. Really on the EOC, you don't need a whole lot of equations. It's mostly conceptual stuff. But there is some stuff there if you want it as a guide.